Before I start making components, I will briefly describe the simple instrumentation system I will create today. This will assist you in understanding the Instrument Manager workflow. From this diagram, you will see that I have 8 instruments, 4 flow transmitters and 4 conductivity sensors in 2 different areas, Field 1 and Field 2. In each area I will have a junction box, JB1 and JB2. These junction boxes will contain terminal strips, XJB1 and XJB2. The instruments connect to these JBs. From each junction box, a cable will run to a terminal strip, s.r.l, in a marshalling panel, MP1, in the control room. There will also be a PLC cabinet in the control room, DCS1, and inside this I will place an 8-input analog I/O card. I will connect wires from the marshalling cabinet to this card. After connecting wires and cables to devices and terminals, I will show the deliverables output, such as loops and datasheets for these components. The system I have described will give you an idea of the workflow in an Instrument Manager project. However, there will be other components in my project that I will use to show you other Instrument Manager features and deliverables. For familiarity, I will firstly give you a quick tour around the Instrument Manager user interface. The user interface is easy to use and intuitive. The first thing to note about the user interface is the tree control on the left side. This allows you to navigate around your project. You can work on your project's components, output diagrams, templates, cable routing, and other facets. We are interested in components first, so I will open up the Motors folder from the Devices branch of the tree. The right side of the screen contains the list views associated with the current tree selection. The top list contains the components in the folder, and the lower list contains the ratings data for those components. With the components in the list view, you can select a specification from the catalogue, add a datasheet or loop, and globally edit components. If I click on the toolbar button displaying the pencil, I can switch to an edit view. The edit view allows you to do basic editing commands on one or more components. These views can be sorted and filtered using the title bar. I can simply type a tag name change and the database will ensure that the tag is propagated to all the places that it is used, a big advantage over working with Excel. The Edit view also contains many advanced electrical functions that you will not find in basic spreadsheets. You can, for example, execute cut, copy and paste commands, doing surgical inserts and removals in a designated part of a column of data or tags. Incrementing values by sequence and replacing bulk data with a file of replacements are both very useful in the instrumentation and electrical disciplines. If I click the toolbar button displaying the blue connection icon, I can see a connection view. The connection view has 3 component trees that allow you to drag and drop components onto each other, and that creates connections. Below that, we see a connection preview window, currently showing a terminal strip and its connections. When I select an instrument, the preview window traces the instrument signal circuit and previews the loop for the instrument. When I select a cable, the preview window displays all of the cable cores and the terminations on that cable. I will now return to the list view and create some components. With Instrument Manager, there are multiple ways to build your project, starting with manual component creation. Firstly, I will select the Areas folder. Then I will use the Add function from the right button menu to create myself a new area. My areas will be named Field 1 and Field 2. I can make these in a single operation by setting the first tag name in the area builder and the number of areas to be 2. My 2 new areas are displayed. Now I will create some enclosures. I will select the Enclosures branch and the Enclosures folder. I will use the add function to create two junction box enclosures. My junction boxes will be named JB1 and JB2. I can make these in a single operation. Junction boxes have many electrical specifications. I will select the specifications from the EDS catalogues. I will select the Hoffman manufacturer and choose a hinged cover galvanized box. The EDS catalogues are customizable. You can add your own manufacturers and part numbers. You can also add as many specification columns as you wish. I will set the number of enclosures to be 2. My 2 new junction boxes will be displayed. Now I will create some terminal strips for my junction boxes. I will select the Terminal Strips branch and the Terminal Strips folder. I will use the add function to create 2 terminal strips. My terminal strips will be named XJB1 and XJB2. I will select the terminal from the EDS catalogues. I will select an AB1 series terminal. I will set the number of terminal strips to be 2. I must also set the number of terminals in each strip. In this case, I have set this to 30 terminals. My 2 new terminal strips will be displayed. I can quickly parent the terminal strips inside my new junction boxes. I will now create some instruments. I will create some flow transmitters in the Instruments branch and the Annubar Flow Meters folder. Again, I will use the add function to display the builder. My flow transmitters will be named FT001 through FT004. From the EDS catalogues, I will choose a generic sample part provided. In this sample, we have configured a default cable to use with new inserts. I will set the number of instruments to be 4. Instruments are configured to offer to add and link a new default datasheet, loop, and a new hookup diagram when created. I will accept the offer. My 4 new instruments will be displayed. I will now take a closer look at FT001. Note that there is a cable created and connected to the instrument. The cable cores are terminated to the instrument terminals. I will now create 4 conductivity sensors. This time, I will filter the catalogue to find the part by description. I can simply type in the first few characters. I will again choose a generic sample part from the catalogue. I need 4 conductivity sensors. I will confirm that I want a new datasheet, a new loop, and a new hookup diagram. My 4 new conductivity sensors will be displayed. I will now create an 8-input analog PLC I/O card. As you would expect, this has a more complicated builder than the other components. However, the process is still quite similar. Firstly, I will select the card part number from the catalogue. The PT config and the PT term list fields define the structure of the cards. The card I want is an 8-input analog card. I will now give my card a tag name. I will now set the start address, rack and slot for my card. I/O cards can have descriptions loaded for each I/O. These can be pasted from your PLC programming system. My card will now be displayed.